Hi, welcome back for another 6 Caillou challenge called Roman Numerals Encoder. You are given an integer as input in the range of 1 to 3,999 inclusive, and you have to convert that into a string representation of Roman numerals. Hopefully you're familiar with Roman numerals, but if not, you can check the wiki page. They've got the key here in case you forgot some of those values. They range from 1 to 1,000, where m's 1,000, d is 500, c is 100, etc. And so I think the directions are very clear. Just convert the integer to a Roman numeral. Remember that with numbers like 900 or 9, the way you do it is you put a preceding character. So C is 100 and M is 1,000. So it's like 100 subtracted from 1,000. That's how you get the 900. So there's some, that's a little bit different. That may throw you a curveball while you're trying to implement this. But go ahead and give it your best shot and come on back when you're ready. So what I'm going to do first is to try to solve this in a common way that you may find yourself in where, here, I'll just start typing. Let's say you have some strategy that's going to go where you make some helper methods that say something like get thousands, and you would pass some input plus get hundreds. Imagine these all return strings and you're concatenating them together. Plus get tens, plus get ones. And you can imagine this strategy takes a number of forms. So it's something like this, and then you put the Roman numerals for each of these places together to form your final answer. And so when we go about doing this, we're going to find that the thousands is sort of a trivial case because of the limited input here. And I don't know if there are any, I don't know what characters are above M. To be honest, I didn't go to the wiki page. I don't know if they had bigger characters, but anyway, that's a side discussion. Not important here, but this one's really easy. You just take the digit in the thousands place and put that many M's. You don't have to worry about, like with 900, we had to do CM. In 9, we have to do IX. You don't have to put a lower denomination in front. So that's why this is a really trivial case. But these other three, what you find is that they repeat. And so I wanted to show how this kind of works in real life, because it happens a lot when you program, where you find yourself doing repetitive tasks, and then you have a chance to refactor and improve your code. So we'll do that. We'll see how something like that, how you could fall into that and how you would improve it. Now this is, again, a coding challenge page. I don't think it's bad to just go right for the solution and not make a generalized answer, but I'm trying to teach programming here, things that you can use in the real world, so that's why I'm going beyond this. Certainly when we submit, we'll see much easier solutions than what I'm going into. Though mine's not very hard. We'll make a few objects and instantiate them, and then it's done. But before we get to that, let's say you were going to do it this way. Private static string get thousands, and you have to pass it a value saying how many thousands there were in the number you're looking for. And so this is really easy. Basically, we just take the letter M and print it that many times, right? If it's 3,999, we have 3,000s, and so you give MMM for that. So we can do that by saying enumerable repeat. I'm sure you've seen me do that before. The letter M is the first parameter to repeat, is what you want repeated, and then you tell it how many times. Well, it's the number of thousands. And then remember, these enumerable methods, they return IEnumerable collections, and so that's clearly not a string, right? A IEnumerable of character is not a string, so we use this little technique to convert those back to strings. You can use string join, where the first parameter is the delimiter, what you want to appear between each character. In my case, I just want MMM all together, so that's why I left an empty string there. And then the second parameter is that collection that you want to join, and then I need a closing parenthesis on there. So something like this will give us the number of thousands. Okay, that part was trivial, easy peasy. Now when we get into the get hundreds and get ones, it gets, a little more interesting. Still not difficult at all. So you could do this and go, yeah, let's think of what our oddball cases are. So 9 is clearly 1, 4 is 1. You got the same thing that kind of happens. Remember, in Roman numerals, from the perspective of ones, 4 is IV. It's not 4 I's. And they told you that in the description. You should never have a character repeating more than 3 times. And same with 9 is IX. You don't write V and 4 I's, or you don't write 9 I's. It's against the rules. So let's handle those special cases. If num hundreds equals 9, we'll simply return. We're dealing with hundreds here, excuse me. So you take the next bigger denomination, subtract 100 from it, that would be 900, right? And same for 4. If number of hundreds equals 4, then we leverage this midway point, which is D is 500, right? So we could subtract 100 from 500. We could say CD for 400. Okay, so now we get to the more general case. Let's handle that. So we could say if num hundreds is greater than or equal to 5. That means we're going to have a D in the answer, right? So I could start setting this up. I could say string result. And then over here, we can say result plus equals D. We start with the 500, and if it's higher than 5, we will add the correct number of C's to that. So what you could do to get that is say num hundreds minus equals 5, because we already accounted for those by putting the D in the answer. And then finally, whatever we have left, we can add. You could use the enumerable repeat method here. If this is weird to you, I could do a looping example too. You could say for int I equals 0, I is less than num hundreds, plus plus I, standard looping, right? And result plus equals, for hundreds it would be C. And then finally, return your results, something like that. And remember, this is okay because I subtracted 5 out when I added the D if I needed to. If it wasn't above 5, and remember it can't be 4. If it was 4, we would have exited this function already, so it would be 3 or less. Then it's 3 or less, and you get 1 to 3 C's. Or 0, it could be 0 and you get nothing, which is good. That's what you want. So something like that works. Okay, great. Now, when you do this with tens and ones, let me show you. You could start coding it out, but what you're going to find is that you're basically doing the same thing. Here, I can expand this too. I keep forgetting to do that. So you'd call it get your tens, and you would have a number of tens passed in. These you can just say n or whatever you want for your parameter name. In fact, I should copy that. And you're doing the same thing. You're going to go check that. You're going to say if it's equal to 9. And the only thing that changes, right, is going to be the sort of denominations that you're working with, if you'll allow me to use that term. It's the letters are going to change. So if you have tens, 9 tens would be 90. You would subtract 10 from 100 to get your answer. And if you had 40, you would subtract 10 from 50 to get your answer. And then if number of tens is greater than 5, you know you need that L, and then subtract out the tens that you already accounted for, and then finally go through your loop, and you'll add in X for each remaining 10 that needs to be accounted for, and then you return your result. And I won't bore you with doing this for get ones, but it's basically going to be the same thing, where the values would be what? IX here and IV here, and this would L would be a V and this X would be an I. And so as you're typing these out, you know this happens in real life. You see you're repeating yourself, so you stop for a minute, you think, okay, Is there a way I can generalize this and write this logic once instead of writing it a bunch of times? It's not so bad here because we only have 4 digits to account for, but this was a constrained example. In real life, you have numbers that can be quite large. And could you imagine repeating this 10 times if you had a 10-digit number? I mean, that would be ridiculous. We don't like to do that in programming. So the idea I noticed is that working with the idea of these dominations, this framework's going to stay the same, but if we set up a way so that we're using the correct denominations with the correct decimal place, the digit in each position, then we can just use the same code over again and just insert the right letter values to sort of pull from. So I'm going to make a strategy that does just that. You could continue with this if you want to see this idea work. Just remember that when you pass in the get thousands, you have to give it just the digit for the thousand. So you could go like n divided by 1,000, I think would work. And then some of these other ones, you have to take modulo 10 to get the digit. We'll handle that with the second example, but I just wanted to show you that this is kind of a common way of going about it, one that you likely may have tried to do. And it's fine. You can do it that way. This is a small example. You can get away with that or any variation of that. But let's go ahead and improve this, in my opinion. So I'm going to go ahead and delete, maybe I'll keep one as a reference that we can refer to when we make the method to do this logic. So what we'll do is I'll get rid of this. We don't need, well, I'll keep, we're going to copy that. We're going to implement that too. So don't worry about it. So the first step I wanted to show you is that I made this private class that I called charset. And the idea here is that we set up a set of Roman numeral characters that correspond to each digit position. And so you can make three or four of these objects. We'll only need 3. Load it with the correct characters. And then for each position that we're at, hundreds, tens place, ones place, we can pull from the right character set. And then we'll get these answers. We'll say, hey, put the single denomination in front of the larger denomination, and put the single denomination in front of the midpoint denomination. And it will insert the right values in there. So we can say public char, I'll call it single numeral. We'll make public char midpoint numeral. And we'll say public char, I'll call it GSD numeral, short for greater significant digit. If you have a better name for that, go ahead and insert it. And then I'll just make a constructor so we can make these objects. It'll take in a char single, a char mid, char GSD, and then the body of the constructor is just really simple, just assigned to your local fields here. Single numeral equals single, midpoint numeral equals mid, and GSD numeral equals GSD. Not sure if I needed to capitalize the P in point. You could consider those probably one word or two. You can ask the English Nazis if I spelled that wrong. Or do whatever you like. As long as you keep it consistent, it'll work. So good. Just a really simple data container, right? Char sets that will have the collection of the values we need. It's 3 for each position. So with that, I would like to introduce the concept of a digit. This is one of those positions in the number. We're working with 4-digit numbers, so we'll have 4 of these. And let's see, we're going to construct these objects. And I'll kind of just set this up for now. And we're going to have this idea of public string numerals. So we're going to locally store the numerals for each digit. And remember, it could be more than 1. If you have a number like 9 or 4, it's 2 characters long. But if you had a number like 1, it would just be 1 character long. So that's why I just made it a string. I'll call it numerals. Could be 1 or more. And I'm going to set this up as a property. I'm using get, which is public, meaning anyone can access this value. And I'm going to use protected set here because, as you'll see, I'm going to subclass the digit class because we have this thousands digit. That's a unique case. It's a really trivial case, and it doesn't work quite the same way. So I use protected here, which means that any subclass of digit can also change the numerals field in the class. If I didn't have any subclasses, I would call that private just to restrict the access. But it's like I'm slightly opening up access to this property to any class that derives from digit. And we're going to do that. It's going to be private class thousands digit. And remember, we use a colon and then say the class you want to derive from. And when we do this now, thousands digit is a digit, so it has this field in it already. And when we write logic inside this class, we can actually manipulate this value. If we didn't have that access, we could not. So if you don't believe me, try setting this to private and then manipulate numerals inside of your thousands digit class. But before we get there, let's continue with digit. So for digit, let's see, where were we? The digit class, we've got our numerals, we've got our constructor, and the idea is in the constructor, well, let's do this. Let's add our character set. We know we're going to need that for each digit. So we can say char set, we'll call it chars, you call it Roman numerals, whatever you like. And we're going to have a private field here, char set, Roman chars, I'll call it. And so one part of our constructor is going to be to say, hey, assign this variable so you have your character set on hand, right? And then the other component to this is I will say we're going to make a local method here that's going to be virtual. That's going to be load numerals. That's going to sort of set this field up with the characters it needs to have. So what I'll do is, and remember, we wanted to do something different in the thousands digit class. So that's why here I'm making it protected so it's accessible. And I'm going to say virtual void load numerals. It doesn't need to return anything because it's already has a field here. It's already got a string variable allocated that's part of the class that we can set the value in. So I don't need to return anything to anybody. And we'll say load numerals. And clearly we're also going to need to know what that digit value was. So I'll just call that val. And then in our constructor, once we set our character set, we can actually call load numerals with that val. And we got to match up our signatures there. And so the idea is as soon as you create the digit, go ahead and use the input provided to set the final numerals for that digit. You don't want to, sometimes people make a mistake and they'll make a separate method that, so when people construct something, they have their object, then they have to call another method to load data that, in my opinion, should have just been loaded on their behalf already. You just add extra work that doesn't need to be done. So that's why I'm handling this in my constructor. So I got protected virtual void load numerals, and this is that opportunity, digits like the hundreds, tens, or ones, where we get to implement this logic one time. We can do it here, and then we don't have to do it 3 times. So let's see, I won't copy, I'll rewrite it. And one thing that I didn't mention before that we could take the opportunity to do is some little input validation. It won't come up, you don't need this, but in real life, you'd probably want it. So clearly the val should be a single number, right? You can't have double digits in a single digit position. That's nonsensical. So we could say, just throw some kind of exception, throw argument exception, invalid input. I'm not gonna spend a lot of time with the error message. But anyways, after that, then we can handle our normal case. So we could say, look I'm just gonna look at this hundreds method that we saved And I just got to implement the same thing, but it's slightly different because we're not returning a string, we're setting a local field. So we're going to say if val equals 9, right? And we're going to set the numerals in that case. So we'll say numerals equals, and now remember, part of our class here, not only do we have this public string that everyone can access, we have hidden behind the scenes our char set, because no one outside the digit class cares about our character set. It's helping us get the job done that we need to get done. And again, if I made this public, it only allows opportunity for people to accidentally modify it, or it's more code for people to consider who are working with our class, so just don't do it. But anyways, we have this character set on hand that we can use. So we can say for the numerals then, do you remember for 9 we wanted the single and the next higher one, what I called the GSD. So we could say Roman chars, look up here, it has a single numeral property, single numeral plus Roman chars dot GSD numeral. Do you see how that works? And then one thing I'll add here, you'll run into an error if you don't quite handle this. I'm going to convert one of them to a string. It doesn't matter which one, but oh wait, I'm sorry, I wrote this in the wrong spot. Let me just steal this. I don't want to mess up our property there. Sorry about that. And paste it in here. So yeah, we're writing to numerals. Roman chars, we're accessing our character set. We're grabbing that single numeral. And I just made it a string because we need a string at the end of the day because numerals is a string. And so when one of these is a string and one's a char, the compiler knows how to handle that and knows it should convert all this to a string. If you leave 2 chars and try to add 2 chars, remember chars are an integral type, so you'll get some kind of message saying you can't assign an integer to a string, I believe, if you did that. So if you don't believe me, just omit that and you can check the error message that pops out. But this should be good. And then we got the same thing for 4, right? If val equals 4, that's our other oddball case. We're going to say numerals equals Roman chars. This time it's the single again. And it's going to be combined with the Roman chars midpoint, right? IV in the ones place. So midpoint numeral. Good. Got those oddballs out of the way. We can handle the more general case. I'll scroll down so you can see the get hundreds method, how we make the translation there. So we could say if val is greater than or equal to 5, then we know we need to start with the midpoint, right? So we'll say numerals equals Roman chars midpoint numeral. Okay. We know we need to start with that. And then let's say val minus equals 5. We'll take 5 away, so we don't. They're already accounted for in our answer, right? Just like down here. And then we got to go through the rest. And we can say, instead of the loop this time, maybe I'll go back to enumerable. Numerals plus equals, we're going to concatenate onto it. And we could say string join again. And then our enumerable repeat. And what do we want repeated? Well, now we're dealing with singles, right? Roman chars single numeral. And then how many times we want it? Whatever's left of val. It may have had 5 subtracted from it if necessary, maybe not. So no, yeah. Okay, we might need a 2-string here too. I'll let that one blow up for us. And we can add a 2-string when that comes up. So numerals looks good. At this point, we've handled all of the cases. We've translated this method here. And now it's generalized, though. This is the beauty here, to the digit class, which we're going to repeat and take advantage of. So the only catch to to handle now is this thousands digit, which you'll like because it's even simpler. So we're going to have a public thousands digit constructor. It clearly needs a val as well. And there's no char set for thousands digit, right? It's just all m. So I'm not going to have that in my constructor. Don't put unneeded information in your constructors. And then the way we can sort of pass this along to the parent class's constructor is using the base keyword that invokes a constructor of digits. So it'll drop us in here on that statement. And then this one most certainly does need a val and a char set, right? So what I'm going to do is say, give it the val like usual, and I'm just going to pass null because I don't need it. Okay, and then the second part is that we don't want it to do load numerals. We don't want it to execute this logic when we're dealing with a thousands digit, right? There's no 9, there's no 4 even. It's just straight this part, enumerable repeat m's however many times. And so this is where we get to take advantage of making this a protected virtual method. So what we can do for that with our thousands digit, we can say protected override, meaning we're overriding the virtual method. Virtual keyword makes methods eligible to be overridden. If I didn't have that virtual keyword there, we couldn't override it. It would just sort of replace it. And void, again, the signatures will match. Load numerals int val. And then it's going to be, basically this will tweak it to make sense in our digit class context. We're not returning a string because it's a void type, right? What we're going to do is say numerals equals that. And remember, I can access numerals, which was defined in the digit, the parent class, because protected is set. And I should say I can write to it. I could have accessed it just to see the value, but since it's protected, I can modify the value. Notice I'm assigning it here in the thousands digit class. So there's no num thousands, we call it val. That's our parameter name here. And really the thousands digit class, that should be it. It's that simple. So since I've used these references, I think they've lived their life. I can clean those up. So now we have these really handy classes here where we can make digits that automatically will generate the Roman numeral characters when given the value they pertain to. So we'll make one final class that sort of leverages all this work that we've done. Private class Roman numeral converter. And we're going to have a constructor Roman numeral converter int val to convert. Okay. And so for our Roman numeral converter class, we will, instead of putting all the logic in the constructor, I'm going to go ahead and make a little helper method to take care of that. And that's a pretty common thing I do. I use these initialize functions that I call inside the class itself. So I'll say initialize with the val to convert. Okay, and then of course we have to define this method, private void initialize with int val to convert, or whatever parameter name you like. So this is where we can do the work. Also, the Roman numeral converter class is also going to have a numerals field. Should note that it's a string, we need a type. And I'll use the property get, and I'm going to say private set this time because I'm not going to subclass Roman numeral converter. I don't have to worry about giving any extra access out to the string numerals. But whoever's using our class can just get the final result here, and that's how we'll solve the problem in the main method of the challenge. So good. Initialize then has the job of setting up the numerals for each digit and combining them into one overall answer. That's what we're going to achieve here. So let's make a couple extra fields that can help us do that. And one that's going to be really helpful, we'll make a private dictionary int to char set, and we'll call this position char sets. So it defines the character sets we should use for each digit position. New dictionary int char set. And I'm actually going to initialize it right in place here. We can do this with these curly braces. And so notice I'm going to start with 1. I'm going to look at the number to convert where we read it from left to right, where the most significant digit is position 0, the hundreds place would be position 1, the tens place would be position 2, and the ones place would be position 3. And so I'm skipping 0 because remember with our thousands digit class, we didn't have a character set, so I don't need this. So that's why I skipped 0. And then I'll associate the value 1, or I should say position 1, with the hundreds place. So remember what our char set class takes, the single, the mid, and the GSD. So you've got to put those values in for the hundreds. What would that be? What's a single and 100s in numerals? It's C. What is the midpoint? It was D, that was 500. And what is the next higher denomination? It was M for 1,000. And so that's my hundreds place. Let's do the tens place. Char set, what would it be? What's the single in tens? It's X, the value 10. What's the midpoint? It would be L for 50. And what's the next higher denomination? It's C for 100. And then finally, we've got the ones place. So I can say position 3, new char set. What's the single? It's I. What's the midpoint? Midpoint's 5, which is V. And what's the next higher denomination? It's X, 10. Okay, so we've got our dictionary. You can probably already imagine how this will be useful for assigning the appropriate character set to each position. And then I'll also add a field, private list digits of type digit. I'll call it digits. New list of digit. And remember, thousands digit is a digit, so I can put a thousands digit in this list because it's derived from digit, so it can be regarded and handled as a digit. That's the power of polymorphism. So we got the list there. I think we can start implementing this initialize and make this all jive. So the way I'm going to get the individual digits, I'm going to convert it to a string and then sort of access the character at each position and translate it to an integer. I know in other challenges I've made helper methods that will take an integer and return a list of ints with each digit separated out. You can do it that way if you want to. This time I'll do it with converting to a string. So for that, I'll say string numText equals val to convert to string. And there's one little extra thing I got to do here, right? Imagine if you had an input like 1 where it doesn't have 4 digits, or 300 or 27. It's going to throw our processing off. I want 4 digits. Even if they're zeros, I want them there so I can get the right characters in the right place. So you may recall we've used pad left in the past, and it will add leading zeros basically where I need them. So I can always count on it being a 4-digit number, which is what I want. With pad left, you're free to look this up. In fact, I think I have the tab open. You specify the total width and the character that you want to pad with. So I'm going to use this second overload here. Let me go back. Pad left. Where was I? Here we go. So I want 4 digits long total and the character 0 to pad on the left side if necessary. Pad left is smart enough to know if there's already 4 digits, you don't have to add any zeros. So we've got our numText, which is great. Now we can go over each of the characters, which we're guaranteed 4 at this point, and process them. So let's just use your good old-fashioned for loop for that. Int I equals 0. I is less than numText.length, and increment I. Nothing crazy there, our typical for loop. And so for this part, let's get each individual digit. Int digit equals, first of all, num text at I, right? That'll give us the character representation of that digit. And I can use the int32's parse method to convert that to an int32. Okay. And then, yeah, actually, if I try it like this, I think we'll get an error. So what I should do is, remember, num text at position I is a character, so I can just force it to be a string, and then int32 can parse it from the string. In real life, you might need some error detection here, but it won't come up in this example. But always think of it. Always be on the lookout and thinking what can go wrong. What can go wrong will go wrong. So now that we have our digit, let's just load up our digits collection, right? Remember we had that special case, so I'll say if I equals to 0, that's the thousands place. We'll say digits equals new, we want to add to the collection. It's a list. And to add to a list, you use add. So add new thousands digit with the digit. It'll make a thousands digit out of that. Good. Else is everything else. Hundreds, tens, and ones, and those will all be handled the same. Digits, add new digit with our value to work with, and then we need the char set. Well, aren't you glad we made this dictionary hit here? Takes care of all that for us. We can say position char sets I. Look at that. Remember, it's going to be 1, 2, or 3 in this part. We didn't make a 0, so no problem. And we'll get 1, 2, and 3, and it'll make a digit, put the right character set in that class for it to work with, and execute the same logic that we only ran once. That's great, isn't it? So after this loop, we have our 4 digits. And now our job becomes easy. We have to set our numerals, right? We have this property that we're going to make available to the public, so users of our Roman numeral converter class can just access this numerals field when they want their answer. So to finish our initialize method, we'll say numerals equals, and I will leverage the aggregate function that we used recently to do this. So since digits is a list, it's an IEnumerable, I can use link methods, aggregate. We did this in a recent video, so hopefully you remember this. I have lots of videos with aggregate though, and you ask me questions if you need to. So digits aggregate, we set our seed value, which is just an empty string. It's going to be blank to start. Then we have 2 parameters. We're going to name one that's just going to hold the running total that starts with this seed value. Let's call it numerals. And then we need a parameter name associated with each element of the digits collection. So how about digit? That makes too much sense, right? And then for our body, all we have to do is say numerals plus equals digit numerals. How good is that? See, with our digit class, the public string numerals, each digit, I can just pull its numerals. So it'll start at the beginning and go through each digit and grab each of them, aggregate them, you can think of it like building them together, concatenating all those Roman numerals for each digit, and put that in the final answer. So assuming I typed everything correctly, that should cover us. Yeah, that's it. So I'm going to go ahead and back out here, and let's see. Before I get ahead of myself, we got to implement the answer. So with this upfront work now, the task is incredibly simple, right? You could say, here, if you want me to break this into steps, you can go Roman numeral converter. Let's call it numerals, or I'll say converter equals new Roman numeral converter, n, return converter dot numerals, right? This is the idea, is that people who use our ultimate class, look at how easy. All they have to do is just instantiate it and get the answer. They didn't have to worry about any of this stuff. We took care of that. So you make life easy for your people, or often it's you. But anyways, let's run this. Let's see how many typing mistakes I made. Oh, some using statements for sure. So type or namespace, name list could not be found. We did not define list. And we know that we have to go to system collections generic to get list. And that will cover dictionary as well. That's where it resides. And I'm going to go ahead and add in using system link because we used aggregate and didn't define that columns that's already implemented. So let's try this. The name Roman chars does not exist in the current context on line 70. Let's scroll down. Line 70. Oh, I called it Romans chars. How about Roman chars? And then number 77 cannot convert type char to string. I think that's what I did on purpose to have it blow up. You can practice taking the toString out if you want to see those blow up. Let's make it a string. So we're working with apples to apples here. Try again. Okay, so we got some failed tests here. Expected length 2, but was 6. The strings differ, so it choked on the input IV, which is 4. And it got 4, and then it tried to put a bunch of 4s afterward. So let's troubleshoot this thing. Let's see where we're going wrong. I'm going to take a quick scan here to see if I see anything weird about that. We've got numerals. Yeah, I see what I did wrong. Yep. So I copied too closely to the, remember when we had the get hundreds method, we saved it to sort of make our implementation. I didn't need to do that. And in fact, it steered me in the wrong direction here. So you can see it happening is that with a val like 4, it'll come in, it'll say, okay, I found my case here, val's 4. Go ahead and add the single and the mid, which is IV, and then it keeps executing. Remember before we returned, we're not returning here, so it comes down here at the end, not greater than 5, but it gets down here and says, okay, also join single val times, which is 4, so we get the extra 4 there. So we need some, and this is, yeah, this doesn't make sense. If the val's 9, you're done. You don't want to check if the value 9 is also 4, right? That doesn't make any sense. So maybe I shouldn't have saved the original implementation. And then let's put this, the rest of this in an else case. We don't want, these are separate cases here, not meant to run. Tab that out. So this should be better. Let's see. Let's try this. There we go. That's the green I wanted. Bam. Done. And so check this out. Let me expand this quick. We'll scan over, see if there's anything I got to take out. I didn't have any print statements in here, but you may have, and you may want to remove those. I do before I submit. Yeah, I don't think there's anything I'm going to pull out of here. One thing at the very end, watch this. I'm going to be the cool kid and do the one-liners. We could say return new Roman numeral converter and numerals. Oh, how cool am I now? And the rest, yeah, like I said, no comments, so I'm not going to take any of that out. If you want a quick overview, remember the idea was